The next question wants me to plot an acceleration versus time graph for this velocity versus time graph. In order to do that, I need the velocities in these time intervals. Now, the time intervals that I'm using for this are a little different than the displacement time intervals. I'm going to be going from 0 to 5 seconds, 5 to 10, 10 to 15, 15 to 20, and 20 to 25 seconds. I don't need to worry about breaking this segment up into two different shapes because it crosses the x-axis when I do acceleration. The equation for acceleration is going to be the change in velocity over the change in time. So that is your final velocity minus whatever your initial velocity was divided by the time change for that interval. I'm just going to take a second and label my time intervals on my x-axis here. So I'm going to use every 2 blocks to break it up. Okay. So for my first time interval, my acceleration is going to be 7 meters per second minus 4 meters per second divided by 5 seconds, and I get 0.6 meters per second squared. The next one is negative 5 meters per second minus 7 meters per second divided by 5 seconds, and this one comes out to negative 2.4 meters per second squared. Okay, here are the rest of the accelerations calculated. A3 is negative 0.2 meters per second squared. A4, there is no acceleration. The velocity is constant, and you have a flat horizontal line on the velocity time graph. A5 is 1.2 meters per second squared. So now I need to just plot these on the graph and draw them in. Okay, so here are my accelerations plotted. 0.6, negative 2.4, negative 0.2, 0, and 1.2. For this next graph, I need to draw the position versus time for the toy train. In order to do that, I have to kind of go back to what's going on in the velocity time graph using those time intervals and those displacements. But I have to remember it started at 2 meters, so I have to add 2 meters to all these displacements to figure out where it is at those different time intervals. The curve of the line is dependent on if it's a positive acceleration, a negative acceleration, or if it's a constant velocity with no acceleration. So when I look at this graph, I know that if there's a positive slope, that's a positive acceleration. Negative slope, negative acceleration. If it's horizontal flat line, 0 acceleration. Starting at 2 meters, and then I end up at 29.5 at 5 seconds, and that's a positive acceleration, so this is a curve up. From 5 seconds to 8 seconds, I have a negative acceleration, and at 8 seconds, when we look at this graph, it's at 0 velocity. So I need to make sure the curve flattens out at that point. And that's what's going on right there. Change of direction. From 8 seconds to 10 seconds, I continue with a negative acceleration, and I end up at 35 meters. And then the next segment is a continuing negative acceleration at a lesser value, and that brings me to 7.5 meters. Then I have a constant velocity up until 20 seconds. And then from 20 to 25 seconds, I have a positive acceleration, which is why the curve is starting to go in the other direction.